You know when you order something online and when it comes in, it's not quite what you expected? The prototypes for the FRX RS front motor project came in. They're a little hefty. I'm not sure if you guys can tell on camera. So when I was setting up my files and going through the process of ordering through Sen, I figured 7075 series aluminum was going to be a good option for this chassis. Unfortunately, or fortunately, they only offer 7075 in 3.2 thick millimeter aluminum stock. So when I ordered these, I had the idea that it might be applicable for a drift car chassis, but unfortunately I'm thinking this is going to be a little too thick for a final product. Hey guys, welcome back to Shredcraft RC. I'm Cam and this is episode 7 of the FRX RS front motor project. So today we are working on the prototype chassis for the FRX. And what I did was I sent my files out to Sen and had a couple prototype pieces delivered so we can test them out and see how they work on the stock chassis. So we are beginning the development stages of these parts, and I want to make sure all these parts fit and have a nice finish before they are available for you guys to purchase. In today's episode, I'm going to go through and try to remove as much material as I can from this hefty chassis, along with countersinking the holes and then showing you guys how I get them all polished up and looking good. What I'll probably do is a live stream episode building the chassis and putting it onto the stock car, making sure all the holes line up and everything fits nicely together. I had this lower deck cut out of 3.2 millimeter 7075 aluminum, and I figured we'd throw it on the scales here and see what it weighs in at initially, and then after it's finished get a weight check and see how much material I was able to remove to see if this will still work for a final product. So toss it on the scales here, see if I can get you guys to see. We are right at 144 grams, so significantly heavier than what I had for the RDX chassis, which I think weighed in right around 34 grams. We'll take a look at a couple of these other parts. So this is the battery tray, and now this is 2 millimeter 6000 series. I believe it's 6061 aluminum. Right at 23 grams. And then we'll take a look at the front bulkheads here. These are also 3.2 millimeter 7075 aluminum. Probably a little more weight and heft than what we need for the chassis. So those are right at 21 grams. And then what I'll do through this process is some of these holes need to be countersunk and then they need to be finished. There's still burrs on the edge. So I'm going to have these all filed down and I'll show you guys how I do that entire process. So it may be hard to see on this angle, but I always like to finish up the raw cut aluminum edges, smoothen them out, and then give the chassis a final polish. If you can see, there's still the stock aluminum marking on it, and then if you can hear, there's a bunch of burrs on the edges. And what I'm going to do is take some sandpaper and some files, clean this up, countersink the holes, and show you guys how I do that entire process. So the first steps in this process is taking off those tiny burrs that you see on the edges, and what I'm going to be using for this is a fine file here, and I'm just going to go over the edges and smooth everything out, and then as we get further in the process with those tight channels, I can take a small diamond tipped Dremel burr and burr out the inside channels of those diamond shapes on the chassis. So I'm going to get to work here. I'm sure the sound won't be great, but I'm going to start filing down all these sharp edges, smooth it out, and I'll show you what it looks like once the process is finished. Making some progress here, and what I've done is mark the holes that I'm going to countersink with some Sharpie so I don't countersink the wrong holes. And then over here on the battery tray, same thing, and this is pretty complicated just because there are countersinks on the bottom as well. So I'm going to get those going, and what I'm using is this countersink bit, and so this will go ahead and cut the countersinks. And then I have a piece of wood here that I've done a bunch of drilling on, it has a bunch of holes, so I am going to drill these out and hopefully get a shot to show you guys the process. Okay, so I'm getting to the point of assembly, and I started disassembling the stock chassis and then testing out some hole spacing on some of the parts. The battery tray needs a couple fine adjustments, but it's good enough to use and test out. And then I've got all the holes and stuff countersunk on the chassis and the brace, and I wanted to show you really quick that I was able to remove 4 grams from the stock chassis. So if you remember when I first weighed it, it was 144 grams. And then if we put it on now, we're right at 140 grams. So this is pretty heavy, and I think I can get away with a thinner stock of aluminum. And then these front braces, I don't think we removed any weight. And as you can see, the stock ones are much lighter at 14 grams. So again, these were 3.2 mil pieces, and I think I'll be able to get away with a 2 millimeter thick piece. And then the stock battery tray without any mounts, just to compare it to what we had previously at 20 grams. So pretty close to what we had with the 2 millimeter aluminum on this stock battery tray. So I will probably start assembling some of this just to make sure the file for the chassis deck is good. I know these front braces are good to go, but I just want to check the hole spacing on the chassis, and then I can show you what it looks like once I get it assembled, and then I'll bring it to the track and test it out to see if there's any performance gain or performance loss with having such a heavy lower chassis deck. Got the whole stock chassis disassembled, and then just a comparison of what the stock deck weighs. 88 grams. So 88 compared to 140 grams could be pretty significant, but we'll find out when I test this thing. Scales are zeroed out, set up. Here's the car with the battery. So I'm going to go ahead and set this on the scales. And yeah, it's pretty heavy. Maybe 100 grams more than what it was previously. 1352.5 with a heavier front weight bias now at 41% and a rear weight at 59%. So I didn't change anything, didn't change the shocks or anything like that, just bolted on the new parts. And it makes sense since these are the 3 mil upper adapters, and I had to go ahead and put a nut to retain the screw on the bottom of these, and then having the heavier chassis deck. So effectively did not accomplish the goal of reducing front weight and putting weight back to the rear. We can compare these weights to the stock weights that I'll put up on the screen here.
So smooth, it's a masterpiece. We own the track, we're the ones to beat. Shred craft rules, bow down to defeat. Charge it up, let the engines roar. Grab those doors, leave them begging for more. Slide through the chaos, never too late. Send it hard and we control our fate. My engines roar. Grab those doors. Begging for more. Limo, clean slabs calling. The stage is set, rubber burning. We're not done yet. Remote in hand, we carve the flow. Drift like legends, putting on the show. Charge it up, let the engines roar. Grab those doors, leave them begging for more. Slide through the chaos, never too late. Send it hard and we control our fate. Control our fate. Open it on the show. Yeah. Key up. Turn the corner. Feel the grip release.
In this clip here, at the end of the track night, I was playing around with the rear shock positions and the amount of preload I was running in the rear along with the front. So getting the balance of the chassis front to rear. This car out of the box with the instruction manual shock setup, it has a reversed rake layout. So the front end sits a little higher than the rear end. I think that's due to helping the rear weight bias and putting some more weight over the rear tires. I was playing around with some of the preload and the shock positions. I ended up changing the rear shock. I moved it in one hole on the lower arm. It gave the chassis a little more ride height and then a little more shock movement. That could have been part of the issue too, pushing more weight to the front of the chassis, not having a solid feeling with the car. Well, I just got back from Scale Science and driving the prototype FRX on track, and some things that I noticed. The chassis felt a little heavy, like the car had a lot of mass. So when I was driving it in transitioning, I would have to almost lift off earlier than the cars I was chasing, and the car would float deeper into the corners, and then I'd have to get back on throttle sooner. But then I wasn't able to pull out and accelerate out of those corners as fast as the other cars that were driving. And when I say heavy, I'm talking in relative terms. So the FRX with no battery, just the weight, 1,207 grams, and that in comparison to my RDX that I've been driving for a couple years is pretty significant. Here's the RDX, 978 grams. So there is some differences between these two chassis, especially with the front motor and having so much weight over the front wheels. It makes a big difference when driving these two cars back to back. And an interesting thing was that I was able to drive the FRX and then drive my RDX, which is an extremely light car in comparison to the FRX. Feeling how nimble and how much faster my lightweight car was in comparison to this full aluminum FRX, it was quite noticeable. So that's the first real test drive with the prototype chassis and parts. Overall, the car felt solid, literally and figuratively. It's definitely still on the heavy side with its current setup. And it drove all right, but I was still having a tough time staying consistent and being accurate with this car as it's set up right now. I've got a feeling that the servo and the gyro are maybe part of my issues with the steering. You know, it's just a matter of getting used to having a front weight biased drift car compared to driving my RDX. And I think it comes down to as simple as that it's probably going to take some more trigger time and some more seat time to get used to the feeling of this chassis on track. Although I do think there is room for improvement with making the chassis lighter and having a more nimble feeling car closer to the feeling that I'm having with my RDX. So that, along with some more tuning, there are some more things that I think I can dial in and figure out on this chassis. Everything's still to the box stock setup. I'll be going back to the drawing board with the design files and fine-tuning some of the hole placements along with the material choice. And I think on the next rendition, it's going to be made out of 60-61 aluminum. Since there's so much bracing on this chassis, there's no potential of it flexing or twisting or having any torsional forces put on it. It's pretty rigid as it's set up. So making those changes with a thinner, lighter aluminum, and then working on the roll cage files some more to get those a little more dialed in, and then order those prototypes up and see how it works with this chassis. I'm looking forward to dialing in this chassis some more, and I really appreciate everyone that's tuned in and checked out this FRX front motor project series so far. It's starting to pick up some steam, and I really appreciate everyone tuning in. If you're enjoying the series, be sure to hit that thumbs up button. Let me know what you think down in the comments below, and don't forget to subscribe for more awesome RC content from Shredcraft RC. I'll catch you guys on the next one. Thanks. Peace.